All right, from the last video, you figured out that if you take a container of any width, fill it with the fluid, that the pressure is going to be the gamma of the fluid in there times the height to the open surface. So this is actually the pressure above the atmospheric. So if it's 14.7, or if you're up in Denver and say it's 10 or 12 psi up there, it's going to be 10 or 12 plus this pressure. So what can we do with this? Well, first of all, the name manometers, if you've looked up anywhere else, you'd see what a manometer is. It's a way of measuring pressure differences. Let's say we had a pipe coming at you. So this pipe is coming straight at you, and somebody drilled a hole in the side of it, and hopefully they drilled a decent hole. And somebody went down to the local hardware store and bought some Tygon or just flexible tubing that you could see. And they made a U out of it. And then what they did is turned on the, say this pipe went way back here somewhere, some sort of pump back there making fluid coming through it, and it goes on down somewhere else. It just so happens that at this particular location is where you put your hole and you attached your tube to. Now let's say water was going through it, and let's say that the water came to about this level and it just sat there, and say the elevation above the pipe, let's just say it was 10 feet. So we know this is the case. Now what we need to do is use this in order to figure out what's the pressure in this pipe about right there. So what we're looking for is the pressure about right here, if in fact this is 10 foot above it. So the method I like to use is start at a particular location, the interface between two fluids. Now this is air and water. And then the location you're interested in. I'll call this A. I'll call this one B. So you state the facts. Pressure at B, gauge pressure at B is 0. Now I start using moving up and down from my location. So I start moving this particular direction. I move down to here. So if I start at pressure B and then I move down, what happens to me? As I'm moving down, my pressure is going up. So I'm increasing gamma through the water I'm going through, or the fluid I'm going through, H that I went in that fluid. I stop at this particular location. I'll call it C. So that would be pressure at C. Now, what I can do is continue this. I can say, well, pressure at C, I increase, so I'm plus a certain amount. As I move along here, no pressure change. As I move up, my pressure decreases. But I moved to this location. Well, I went down a certain height. I came back up the same height, and then I move across. As I'm moving across, now what I mean by across is here's gravity. So I'm moving perpendicular to gravity. There is no pressure change. So from this I can conclude that. So if that's the case, pressure B, I have essentially these two equations. Pressure B plus gamma H is equal to pressure A. Now I can just say, well, pressure B, we already determined was 0, so my pressure at point A is 10 foot times 62.4, or 624 pounds per square foot if I happen to want to change. I can change it to PSI and get an answer out of it. Now that's a simplistic case. Let's move to a more complicated case. Here, I'll just draw a line across it and say we're moving into a more complicated case. Let's say we have two pieces of pipe. Pipe here and a pipe there. Somebody strung flexible tubing off. Or let's take the same case and add an interface. Let's do this. This time we have water, and then we have an interface right there. Whoop. And here we have a different type of fluid. Now we need our measurements down here. So we'll say that here is, I believe I labeled that A. So here is A. I'm going to label this B. I'm going to label this C. So here's one interface. Here's another interface. This is air, and it's open to the atmosphere. So that tells us right off pressure at C, gauge pressure 0. Now you can go in any particular direction. You can start here and go in this direction, or you can start up here and go the reverse direction. Doesn't really matter. What you have to remember is a simple setup. Pressure I, wherever you're starting from, plus gamma through whatever fluid, the height of whatever fluid is equal to pressure of J. This is plus or minus, plus if you go down, minus if you go up. And these two, these two subscripts need to be the same, and this would be one interface and this would be another interface. So let's start at pressure C. Pressure C, let's just start making up numbers. Let's say this is 2 foot. So we came down, reached this same location, and then we moved up 2 foot. What happens when we move up? We reduce our pressure. Gamma, now I'll call this R for red, and height through the red fluid is equal to pressure at B. Now let's start at pressure at B. What we're going to do here is go up, going up again through the blue fluid, BLUE. Here, let's just, and then the height of the blue is equal to the pressure at A. Now, let's do something interesting real quick. Let's move this to this side of the equation. Only on this one. If we do that, what we end up with is it becomes a minus and it becomes equal to 0. Now, the only reason I don't do it on this one is because this is the start and this is the end. In other words, I can go through, this is what I'm interested in, and here's the other end. If I have 5 or 6 interfaces, I do it all over here. We'll see that in a minute. Then I simply add these equations together. PC minus gamma of the red, H of the red, minus B, but plus B, then becomes minus blue, H blue, equals to pressure at A. Now I can state the inevitable fact that that was 0, and I end up with the pressure at A being equal to, and essentially I get these values here, and that would be minus gamma red, H red, minus gamma blue fluid, H of the blue fluid, and then you're done. Now, of course, I've made each interface below each other. So these two, there's no way that these two numbers can match. These are two different cases. The geometry was shown. But I've put a fluid in here, which was different than this. Let's make it even more complicated. Let's first draw our piece. I'm not doing a great job of that, but or let me just copy the one from above. Alright, I've copied the one from above, but what I'm going to do from this one is this. I'm going to stack another fluid here. Some green fluid. And I'll say this is like 3 feet, or it doesn't matter what the value is. This would be, we can say that this is the H of the green fluid, H of the blue fluid, red fluid, and H of the blue fluid. Now we have a new interface, D. Pressure at D, you could state before you start, was 0, and you could start there. Pressure at D plus, because I'm going down, H through the green fluid, gamma of the green fluid is equal to the pressure at C, the location I ended up at. Pressure at C minus H of the red fluid, gamma of the red fluid is equal to pressure at B. Pressure at B minus H of the blue fluid, gamma of the blue fluid is equal to the pressure at A. This is where I ended up. This is where I started. Everything except this equation, the last equation, you can simply go through and move the pressures on the other side of the equation and set them equal to 0. Add them all up. Now what you've done is you've gone from one interface through the same fluid to another interface. And you've gone down here, and up here. Add them up, and you get, moving them over, pressure of D plus gamma of G, H green, minus H red, gamma of red. Remember, this term cancels that term, and this term cancels this term. And H, height of the blue fluid, gamma of the blue fluid, is equal to the pressure of A. Now, if someone gave you that, you could use it. However, you figured out you wanted to make it gauge pressure. If you did, you just erase all that, and there's your answer right there. All you have to be is given the gamma and the H's, and that's it. Let's do a numerical problem now. Okay, so here's our problem. I've used the highlighters to make it look a little bit better. So what we need is the heights. So let's say this is 2 foot. Let's say this is, let's make it 3 foot. Let's make that 1 foot. Let's make this 2 foot. Now, what you have to realize is, if I've gone down 4 to here, if I've got these drawn where they're the same elevation, then I have to go up 2 more for this geometrically to make sense. Go down 3 and then 1, that's 4, 2, and then up another 2. So if you're ever missed, there's a measurement missing, you have to use your common sense there. So now you don't know the pressure at A or the pressure at E. But somebody is going to want you to know what's the delta P, or pressure A minus pressure E, or just the same way, pressure E minus pressure A. Now, let's just take off. Now, before we take off, we need to know our values. I'll say this is SG equal 1, SG equal to 4, this is SG equal to 3, and this one will be SG equal to, say, 2. Now we have to remember what SG is. SG is nothing more than the gamma SG of F, so whatever fluid, is equal to that over 62.4 pounds per cubic foot. Go ahead and do this and just take off. I'll just pick a point. I'll start at A. I'm going to go down 3 feet. Down becomes a plus 3 foot through SG of 1 times 62.4. Now, that means the gamma of whatever fluid is equal to the SG of whatever that fluid is times 62.4. These two equations are the same thing, just with the gamma, the value brought over. Alright, so that's where I get 3 foot. I go 3 foot through this fluid. This is the purplish fluid, whatever you want to call that, pink, purple, whatever. And you end up at the interface B. You start at B, pressure at B. You go down a foot, down 1 foot through the green stuff, which is 4 times heavier than water. And you end up with pressure at this location. You end up at C. You start at C. Now you're going up. You go up 2 foot through some stuff that has a specific gravity of 3 times heavier than water. And you end up at D. Now you start at D. I believe you go up another 2 foot. You go up 2 more foot through something that has a specific gravity or is 2 times heavier than water. You end up at pressure E. You started, or you ended here, you started there. You can go through these equations, move the pressures over to the other side, add them up, and here's what you get. You get pressure A plus 3 times 1 times 62.4. What is that? That's 187.2 plus 4 is 249.6 minus, okay, that was the 4 times the 62.4. Here I've got 2 times 3 times 2 times 3 times 62.4, 374.4 minus 4 times that, 4 times 62.4, 249.6 equals to PE. Now notice this is what I had up here. This is what I had up here. If I'm looking for the difference, I have to move one of them to the other side. Since this one's conveniently already there, I'll figure out that I'm interested in PE minus PA. That's just equal to this whole term. So if you want to 187.2 plus 249.6 minus 374.4 minus 249.6, and you get around 187.2 pounds per square foot. Now if you want to convert that, some people love pounds per square inch, and if you divide it by 144, you'll get about 1.3 pounds per square inch, and that's the difference in pressure of those two.